Hello everyone, and welcome to section 4.6 of chapter 4, compounds and their bonds. In this, what we're going to do is we're going to look at further at covalent bonds, but we're going to look at a particular type of covalent bond called a polar covalent bond. And this has to do with electronegativity of an atom. So the electronegativity of an atom indicates how much attraction it will have in that shared electron pair in a covalent bond. As you move from left to right on the periodic table, it increases, and as you move down the periodic table, it will decrease. Okay, so it's pretty low for metals, as you see, 1.0, 1.5, 0.8, 1.0. It's relatively high for your metals, your non-metals, 3, 3.5, 4.0. So your non-metals will tend to attract those electrons that are being shared towards them and away from those metals. So the way you determine if a attraction is going to be unequal, that is polar, is you look at the differences in their electronegativity. If you have a very high electronegativity number, then that atom is going to pull those electrons much harder towards itself than you will with one that has a low number. And so when you're looking at this, for example, if you have a difference, like all of these elements will have an electronegativity value. And so if the difference is 0, okay, then it will be equally shared between the two. And you see this typically with when they are the same exact element. Up to 0.4, they can still be shared relatively equally. Between 0.4 and about 1.8, okay, then you're going to get a polar covalent bond and this unequal sharing here, so that it kind of gives you a positive end and a negative end. This little delta sign means partial positive charge, partial negative charge, and that's because it's not a complete separation of those electrons. So you see a non-polar covalent bond is equally shared. A polar covalent bond can be unequally shared, and if you get above 1.8, you're going to get complete transfer, and then when above 1.8 you get what? An ionic bond, because the difference in electronegativity is so great that the element that's the higher electronegativity value completely pulls the electron or electrons away from that other element that has fewer electrons. And you see this a lot with hydrogens, things like that. Sodium, which has one, I should say sodium is typical. So in the nonpolar bond that we see an example of in hydrogen gas, they're shared equally because they're exactly the same. They have the same attraction on both sides of this shared pair. But if you look at hydrogen chloride or hydrochloric acid, depending on if it's in water or not, that hydrogen has one electron, and so it has a very low electronegativity. Chlorine has a very high electronegativity, and so when they share, this tends to be pulled this way. And in this particular compound, hydrogen, doesn't follow a lot of the rules that the others do. That's why we write it on both sides of the periodic table. It does form a covalent bond, okay, but it's a very unequaled sharing of electrons, okay, and so this gives us what we call the polar covalent bond, because this shared pair is going to be pulled closer to the chlorine than it will be to the hydrogen, giving us this partial positive charge on one end and partial negative charge on the other. So a non-covalent bond occurs between nonmetals that is almost an equal sharing. So when we look at these differences between electronegativities, obviously if you have the same elements that are binding together, they're going to have the same electronegativity. So that's when you're going to have a 0 for the difference. That's obviously going to be a nonpolar covalent. But if they're close, 0.2, 0.3, they're still going to form a nonpolar covalent bond. And so you can use this difference to calculate it exactly. A polar covalent bond is when you get over 0.4. For example, oxygen and chlorine, 3.5 and a 3, you get a 0.5. So that does form covalent. Chlorine and carbon, and then oxygen and sulfur have a 1.0 difference. So anytime you have a moderate electronegativity difference, you're going to have a polar bond. Now, when you get up to 1.8 or higher, okay, you're going to have an ionic bond. That is, you get a complete separation. So the differences in electronegativity are so great that the more electronegative element completely pulls that electron away from the less electronegative atom. And so you have that complete transfer of the electron between the metal and the nonmetal. And so this is just a table that's found in the textbook, which shows you these differences and being able to predict greater than 0.4, less than 1.8, you're going to have a polar covalent. If it's greater than 1.8, it will be ionic, and if it's less than 0.4, it will. And it can kind of go either way if it's exactly 0.4, if you're wondering that. But obviously that's beyond our realm in this class, and so you're not going to be expected to make that decision. So in your first learning check, use the electronegativity difference to identify the type of bond, nonpolar covalent, polar covalent, or ionic between these following. And I have added a little table here of the electronegativities for you to use as you're looking at this. So potassium has a 0.8 and nitrogen has a 3.0. So 3.0 minus 0.8 is 2.2. So is that going to be, and remember our cutoffs are 0.4 and 1.8. So this is greater than 1.8, so that one must be what? Ionic. Nitrogen 3, oxygen 3.5. So 3.5 minus 3.0, the difference is 0.5, so that's going to be what? Polar covalent, yes? Cl and Cl, it doesn't even really matter what their electronegativities are because they're going to be the same, but they are 3 and 3, and so 3 minus 3 is what? 0, so that's going to be a nonpolar covalent bond. Hydrogen is a 2.1, and chlorine is a 3, so 3 minus 2.1 equals 0.9, and so that's going to be what? A polar covalent bond. All right, because it's greater than 0.4, but it's less than 1.8. That's why it's a polar covalent bond. And that's the end of chapter 4.6, or section 4.6. Thanks for staying with me. Hope you understand a little bit more about the electronegativities. If not, you have your textbook and you can go back over this video presentation. Hope you have a great day.